This video will explain how you create a typed report, where you summarize the experiment's theory and you also analyze what your experimental results have told you. This document that you're looking at is available on the website. So the first thing you put in your typed report is the identifying information. So the title, the date, your name, and if you have one, your partner's name. So this is exactly the same way that you start your lab notebook. The next thing that goes in the typed report is the objective for the experiment. Again, this can be exactly the same one that you used in your lab notebook. The next thing that goes in your typed report is your theory section. So this is where you're going to summarize the theory for the experiment in your own words. So don't copy what's in the lab manual, but try to state what the theory predicts for this experiment. So that'll be the first thing that you put in your theory section. The second thing you put in is a list of all the equations that you actually used in the experiment, and you also want to define their variables. Now you only need to list the equations that you actually used. So if there's a derivation with several steps in the lab manual, you only want the final one, the equation that you actually used in your experiment. You don't need to include any of the intermediate steps, and also you don't need to include any diagrams in your theory section. The third thing that goes in your theory section is you want to explain how the experiment is going to confirm the predictions of the theory. So what are you going to do experimentally to confirm the theory? Will you graph some data to confirm a relationship? Will you compare a measured value with a calculated value to see whether they agree within their limits of uncertainty? This is the part where you explain the experimental procedure that would confirm the theory's predictions. The fourth thing that you put in your theory section is to list all of the assumptions or approximations that you made. So for example, did you assume that there was no friction? Did you assume that the friction on the cart was the same for a flat track as it was for an inclined track? Did you assume that the weight of something like a paperclip or a string was negligible? Things like that are what you list as your assumptions and approximations. So again, in summary, for your theory section, you should explain what the theory predicts. You should list all the equations that you actually used and define their variables. You should explain how the experiment is going to verify the theory's predictions. And finally, you should list any assumptions or approximations that you made in this experiment. So there's one more thing you need to know for your theory section, and that is that you're going to be making your typed report in Word, and you need to typeset the equations correctly. That is, you need to input complicated expressions into Word and have them typeset correctly so they look correct. So I'm going to demonstrate how you do that now. So in Word, sometimes you need to insert a special symbol into a sentence, and sometimes you want to insert an entire equation. So I'm going to show you how to do both of those things. So say you've got a sentence, and you want to insert a special symbol into this. So the way you do it is you go up to the Insert tab at the top, and then you click on Symbol over here. Now a little menu opens up, and if you see what you want there, go ahead and click on it. But if you don't, you can click More Symbols at the bottom, and it opens up a menu. Now this menu right now doesn't have the right font for the special symbols that I want, so I'm going to highlight the font and just type in Symbol, hit Enter, and it switches now to the symbol font. And this has all of the Greek symbols, and if I scroll down, you see the lowercase ones, and if I keep scrolling, you start seeing mathematical symbols like the degrees symbol and the plus minus symbol and whatnot. So I want an angle, and I'm going to use the theta symbol. So I click on theta on the menu, and then I can click this Insert button, and it automatically appears in my document. And then I can click Close and continue typing. And say I want a plus minus symbol, same thing, go to the Insert tab, click Symbol. If I don't see what I want here, I can click More Symbols, make sure the font is set to symbol font, and then scroll down to find the plus minus symbol and insert it. And I'm going to click back on the document and then add a degrees symbol. Insert that as well before I close it. So to insert a symbol into a sentence, it's just the Insert tab and then the symbol icon over in the Symbols area here. So as I said, sometimes you want to insert a symbol, sometimes you want to insert the entire equation. So let me show you how to insert an equation now. You still go to the Insert tab, but now you click the Equation button. And that inserts a box where we're going to insert our equation. And notice up here at the top, there's a new tab called the Design tab for Equation Tools, and it's got a menu of things we can insert into our equation here. There's also a menu over here of some special symbols. If you click on the corner here, it expands, so you can see some more here. It doesn't have every symbol you might want, however. This is the basic math menu. You can also click this little downward arrow, go to the Greek letters, and then it gives you all the Greek symbols. And if you want to go back to basic math, again, click the little down arrow, switch to basic math. And again, to open this all, you just click this little box in the corner. So I'm going to add a delta. So I open this up and go find my delta symbol, and then F for the uncertainty of the force, put an equal sign, another F, and now I want a square root symbol. So that'll be in this radical menu, so I click on that, and here's the square root. So I click that, and it inserts a square root for me, and this little box inside is where I continue typing. So I'm going to want to put a sum of fractional uncertainties squared here. So to put in a superscript or a subscript, you click the script button, and the first one will give you a superscript, and the second one will give you a subscript. So I'll click on superscript, and again, it gives me box raised to the power of box. I'll add a plus sign and another one of these, and then I'll click into one of these boxes, and I'm actually going to add brackets here, but not the ones on the keyboard. I'm going to use the ones on the menu because they will automatically change size if I insert something really big into the brackets. So I'm going to put a fraction in here. So there's also a fraction icon on the menu, and I'll click the big fraction here, and it inserts one for me. Same thing here, insert a fraction. And so on the top of this one, I'll put delta m, and then I can click the down arrow to get to the bottom, m, so that gives me the fractional uncertainty of m, and then side arrow gets me out of the fraction, another side arrow gets me out of the brackets, another side arrow gets me up to the superscript, so now I'll square it, and then another side arrow takes me out of that whole thing. So you use the side arrows and the up and down arrows on your keyboard to navigate around inside this expression. You can also just click on a box. So I'll make this one delta A, down arrow A, side arrow to get out of the fraction, side arrow to get out of the brackets, side arrow to get up into the superscript, square it, and then side arrow takes me out of the square, and another side arrow takes me out of the square root. So I could now type some more stuff. When you're done with your formula, you can click anywhere on the page and it takes you out of the equation. If you decide you need to go back in and make a correction, you just click on it and it'll take you back into the equation editor. So again, to enter an equation, it's Insert, Equation, and then you use the new tab with all of its menus to create your equation. Something else that's useful is knowing how to do superscripts and subscripts. So say, for example, I've got some value, and I want to put in the units meters per second squared. So going back to the Home tab right here, up in the font area, there's icons for subscripts and also for superscripts. There's also bold, italic, and underline. So I'll click the superscript, and then I can type 2, and it appears as a superscript. And then when I click that icon again, it takes me back to regular typing. So just be aware of those superscripts, subscripts, bold, italic, and underlining. So the next thing to go in your typed report is your Apparatus procedure section. And this again can be identical to what you have in your lab notebook. The next thing that goes in your typed report is your results section. This should be written in full sentences only, and this is where you report your important results from the experiment. So for example, in the case of the acceleration on an incline experiment, you've got 1 experimental acceleration value and 4 theoretical acceleration values. You'd want to put all 5 of those in your results section with uncertainties and units and with everything rounded off correctly. And again, it should be in full sentences, not point form. So the results section is all the important numbers summarized. The last thing that goes in your typed report is your discussion section. This is where you analyze your results and say what they mean. So there's only 3 things that you need to analyze in your discussion, and one of them you won't be doing every week. So if there's a graph, you analyze your graph completely. But we're going to be learning about graphing next week, so I'm going to skip over this first topic. It'll be relevant next week, but it isn't this week. So what you'll start with instead is discussing the agreement of your values. So do these 2 numbers agree within their limits of uncertainty? In the case of the acceleration on an incline experiment, you would be comparing your 1 measured acceleration value to the 4 theoretically calculated acceleration values. So you'd have 4 different statements here where you'd say this experimental value did agree within its limits of uncertainty with the measured value. This next one did not agree within its limits of uncertainty, and so on. So the agreement section is simply stating whether your values agreed with the predicted values within their limits of uncertainty. And the last thing that goes in your discussion section is a precision analysis. So this is where you look at each of your calculated final values and determine what measured value affected its precision the most and what you could do to improve that measurement's precision. So for example, in the acceleration on an incline experiment, you've got one directly measured acceleration. You don't need to do a precision analysis on it because it's obvious which measurement affected it the most. However, you have 4 theoretically calculated acceleration values. You should do a precision analysis on each of those 4. So if it's a calculated value, do a precision analysis on it. So here's an example of a typed report, and like I said, the document you're looking at is provided to you on the website, so you can go and have a close look at this if you want to. But you can see that they start with the identifying information, the title, the date, their names, then they have the objective, then they have the theory section, which starts by summarizing what the theory predicts for their experiment. Then they give all of the equations that they actually used in the experiments, and they define their variables. Next, they explain how the experiment is going to confirm the theory, and finally, they summarize their assumptions and approximations for that experiment. After the theory section, they next write in their apparatus procedure section, where they refer to the lab manual, just like they did in their lab notebook. After that comes the results section, where they list all of their important results with uncertainties and units and all of the values rounded off correctly. And note that all the results are reported in full sentences, not point form. And finally, they have their discussion section. So in the first 2 paragraphs, the first sentence discusses whether their measured value agrees within the limits of uncertainty with the predicted value, and the second sentence says whether or not they have verified the theory with their experimental results. The third paragraph is a precision analysis, so they start by identifying which measured value affected their precision the most, and then they suggest a way to improve its precision by making the fractional uncertainty for that measurement smaller. And that's all you need in your discussion for an experiment that does not have a graph.